Question 2 says a charged particle A exerts a force of 2.55 micronewtons to the right on charged particle B. When the particles are 13 millimeters apart, particle B moves straight away from A to make a distance between them of 16.9 millimeters. What vector force does particle B exert on particle A? And the answer is in micronewtons to the left. So in this problem we have what it seems like is two unknowns. So we have a force 1 at 13 millimeters. So this is the force 1 of A to B, and it's equal to 2.55 micronewtons. And then we have that that the distance at that is equal to 13 millimeters. And then we know that this is distance 1, so distance 2 is equal to 16.9 millimeters. K, of course, is a constant. We really don't even have to know it for this problem, but it's about 8.99 times 10 to the 9th. If you remember our equation, so it wants us to find force 2 of B to A, the force of B on A, and it's the force at the second distance. So if you remember our equation, the force from a charge is equal to K Q1 times Q2 over R squared. We know what R squared is. It's the distance. So this is, we could either be talking about the force at distance 2 or the force at distance 1, but R squared is our distance. We know what K is. We know what the force is at part 1. We need to find the force at part 2. So we don't know F2, and we don't know what either of these charges are. So we're going to have to solve these charges symbolically using force 1, and then plug that into our equation for force 2. So we're solving for Q times Q, and this Q1 times Q2, so it's not necessarily Q squared unless the charges are the same. We don't know if the charges are the same, so we're just going to solve for Q1 times Q2, and that's going to be the force divided by the constant K times the radius squared is equal to Q1 times Q2. That's lower. Now I want to label some of these things. So this is the force at distance 1, and this is the radius of distance 1. So Q1 times Q2 is equal to the force 1 over K times radius 1 squared. Now force 2 is equal to K times Q1 over Q2, or in this case we'll use the equation, so force 1 over K times radius 1 squared divided by radius 2 squared. In this case K cancels itself out, and we're left with the force 2 is equal to force 1 times radius 1 squared divided by radius 2 squared. And if you were to divide this, you would see that you get a ratio of force 2 over force 1 is equal to radius 1 squared over radius 2 squared. And this is because it's the inverse. Whenever you look at the numbers, this is force 2, this is radius 2, this is force 1, this is radius 1. It's because it's an inverse squared law. So we'll just plug our numbers in right here. So the force 1 was 2.55 micronewtons. Radius 1 was 13 millimeters. We're going to square that. Radius 2 was 16.9 millimeters. Make sure you square that. Now I typically make a habit of converting all of my units to standard units because K is written in standard units. So if K was in our equation, we would have to write everything in standard units, but since it's not, your answer is going to turn out the same either way because K canceled out. So you can put 2.55 micronewtons, or you could convert it and say 2.55 times 10 to the -6 newtons, and then whenever you got your answer, you would have to convert your answer back to micronewtons. And this is what I would typically do if my conversion factor wasn't canceled out. But since it canceled out, you're going to get the right answer without converting to standard units. Now if you did all this right and you remembered to square your radius on both the top and the bottom, you should get 1.508 micronewtons as your answer.